So for the warm-up, these are just multi-step equations or equations that have variables on both sides. Remember, for each of the equations, you have a process that you have to always follow. So the process is always going to be first distribute if you can. Second step is to simplify the left side and simplify the right side by doing any operation you can with combining like terms. Then you move on to step 3, which is to start solving by doing inverse operations, meaning that if you have to move a variable to the left side, you do so. If you have to move a constant to a side, you do so. If you have to multiply or divide, you do so. And then you simplify all the way down to what your variable is equal to. So you distribute, you combine like terms, and then you start solving. Okay, it's always the same. So do we have distributive property for problem number 1? Yes. What is being distributed? Eager? Yeah, the negative 5 is going to get distributed to the 3x. It's also going to get distributed to the positive 7. So we are taking that negative 5 and multiplying it to 3x, and we are multiplying it with the 7. So negative 5 times 3x is going to give us negative 15x. Negative 5 times positive 7 is going to give us a negative 35. So we have that portion. We still have the rest of our equation to bring down into our statement. So plus 22 plus 9x is equal to negative 37. So I've completed my distributive property. The next step is to go ahead and combine any like terms that I can combine. So do I have any variable like terms that I can combine together? Yeah. I have a negative 15x and I have a positive 9x. Those can get combined together. Negative 15x plus that 9x. That's going to come out to a negative 6x. I also have constants that I can combine together. I've got a negative 35 and a positive 22. A negative 35 plus 22, that's going to come out to a negative 13. So I now have negative 6x minus 13, and it's still set equal to negative 37. Okay, I'm afraid I might run out of room, so I'm going to go ahead and rewrite it up here just in case. So negative 6x minus 13 is equal to negative 37. I have combined all like terms and simplified this as much as I can. The next question I ask myself, do I need to move variables from one side to the next? Meaning, do I have variables on both sides? Are there variables on both sides of the equal sign? No, so I don't have to worry about that. I am now going to go and deal with my constant. What inverse operation am I going to do to the constant? Aaron. Addition. What are we going to add? Good. 13 to both sides. We're going to add 13 to both sides. That's going to give us a negative 6x is now equal to a negative 24. And then our last step, we have to deal with that constant, that coefficient. We have to deal with the coefficient by dividing. You need to divide both sides by negative 6. You have to divide both sides by that negative 6, and you'll get x is equal to a positive 4. Okay, distribute, combine like terms, solve. That's it. Distribute, combine like terms, and solve. Let's take a look at problem 2. We got to distribute. So we're going to multiply 3 times 4x and 3 times that negative 5. What's 3 times 4x, guys? 12x. What's 3 times negative 5? Negative 15. Okay, we still have all of this that needs to come down. So we still have plus 18 equals negative 4 plus 5x minus 7. Okay, now I combine like terms. What like terms can I combine, Jamez? They're on different sides. Can we combine them if they're on different sides? No, think of it as one of them's inside my classroom, the other one's inside Mr. McNeely's classroom. Can't combine them because we're in separate classrooms, right? That wall separates us, so you can only combine like terms on same sides. Allison. Very good. Negative 15 and positive 18. They can get combined together. They are on the same side. You can combine them. They are on the same side. So when we combine that together, that's going to come out to a positive 3. So I now have 12x plus 3 equals, what about on the right side? What can I combine together on the right side? Matthew. Negative 4 and negative 7. Negative 4 and negative 7 can get combined together. Negative 4 minus the 7, that's going to come out to a negative 11. And then we still have plus 5x. Okay, again, I'm going to run out of room, so I'm going to go ahead and write it up here. Okay, so I now have 12x plus 3 is equal to negative 11 plus 5x. Now I can start to solve. But I have variables on both sides. I have variables on both sides. I can't have variables on both sides. So what do I do? Eker? Very good. Subtract the 5x from both sides. I need to move this 5x over to the other side by doing the inverse of it. So we're going to subtract 5x from both sides where the variables exist. Okay? Those 5x's are now going to be eliminated. They cancel to a 0x. You now do 12x minus the 5x, which gives you 7x. You have 7x plus 3 is equal to negative 11. And now it's just a two-step equation. Subtract 3 from both sides. That gives you 7x is equal to negative 14. Divide both sides by 7. X is equal to negative 2. Okay, so what we've been working on here, guys, are called single solution equations. One solution. There are other types of equations that we're going to be working with today. So what I want you guys to do is down here at the bottom, I've given you two equations that I want you to go ahead and solve. Do the process that we know to do, Brian and Naomi. Do the process that I taught you to do. And then there's going to be something different about them. I want you to make an observation. What did you notice happened when you were solving? What do you think that means for the solution? Okay, you're only working on these two. Doing this on your own. I do not want you to discuss it with each other yet. You will get an opportunity to discuss, but I want you to right now how you would solve number 1 and how you would solve number 2. Something happens. What happened? What do you think it means in terms of the solutions? Go ahead and work those out. So taking a look here, when we've got 6x minus 9 is equal to 5 plus 6x. What's the first thing that we need to do to solve a problem like this one? Kingsley? 6. So we're going to subtract the 6x from both sides. So when we subtract 6x from this right side, that zeroes out and becomes a 0x, right? But then when we do it from the left side, that also is going to cancel out and become a 0x. So then what are we left with? We're left with negative 9 equals 5. Okay, so observations, what happened? Mason? Okay, so if I add 9 to both sides, that's going to give me 0 is equal to 14. Does it change anything out? No. So what did we see happen? The x's canceled out, right? So our x's disappeared, didn't they, essentially? not just x, but any kind of variable in that situation. The variable disappeared. Okay, variable disappeared. What were we left with? Are we left with a statement that is true or false? False. We're left with a false statement. Okay. So what do you think that means for the solution? Is there a solution at all? No. There is not a single number that we could plug in for x that would make this statement work. Not a single value of x will exist that will make this statement work. So what we call this is no solution. No matter what value of x you choose, nothing is going to work. You will not be able to get the left side to equate to the right side. So it is a no solution statement. Now let's take a look at problem 2. Same process, right? We have 8 minus 2x is equal to negative 2x plus 8. If I add 2x to both sides, again, the x's cancel out, don't they? They become zeros. But this time, what are we left with?
8 equals 8.
8 equals 8. Okay, so similar situation. Again, the variable canceled out. Same process. The variable disappears. But this time we're left with a statement that is true, isn't it? We are left with a true statement that whatever was on the left side is equal to whatever is on the right side. So this time we do have a solution. This is called infinitely many solutions. What this means is that no matter what value of x you choose, every value will work. X can equal 1, it will work. X can equal negative 7, it will work. X could equal 22 over 5, it will work. Every decimal, every fraction, every positive, every negative, you substitute that in for x, it will work for this statement. Yes? If it's the same number on each side, if your x gets eliminated and you are left with the same number on both sides, then that is an infinitely many solutions set. If your x is eliminated and you are not left with equal sides, then that has no solution. Now be careful, because a lot of people mistake that, oh, I'm left with a positive 8 and a negative 8. Are those the same?
No.
No. Positive and negative are not the same. So be very mindful of your signs. This is infinitely many solutions. When they are the same, it's infinitely many. Now, if x does not disappear at all, then that's just a single solution problem. We call that one solution. X will equal one value. Okay? So those are the 3 types of equations that we now are going to be discussing. One solution, no solution, infinitely many solutions. They might also just say many solutions or all real solutions. Okay? Go ahead and flip it on over to the back. So, one solution means that when you solve, you are left with x equaling a number. X is equal to some value. That is just one solution. We've been dealing with that for the past week and a half. No solution means x is going to cancel out completely. It's eliminated. And you're left with 2 very unequal values. So a false statement. Infinite solutions, x cancels out, or your variable cancels out, and you are left with a balanced equation, 2 sides that are equal to each other. So that's going to be infinitely many solutions. Okay, so I want you to do these 3 problems on your own. One of them is a one solution, one of them is a no solution, one of them is infinitely many solutions. Go ahead and do those 3. All right, real quickly, we're going to go over this for problem number 1. Number 1, you had to distribute the 2 to the x and the 2 to the negative 5 first. When we do 2 times x, that's going to give us 2x. When you do 2 times the negative 5, that's going to give you negative 10. So you get 2x minus 10 on that side. There's nothing that can be combined with it. On the other side, you still have it set equal to 5x plus 23. We're then going to go ahead and start solving with inverse operations. I'm going to subtract 5x from both sides. In doing so, these 5x's can go ahead and cancel out. 2x minus 5x gives me negative 3x minus the 10 is equal to a positive 23. I can then add 10 to both sides. That's going to now leave me with negative 3x is equal to 33. And then I can divide both sides by negative 3 and get x is equal to negative 11. So that is a single solution. That is a single solution. You get x is equal to negative 11. Problem number 2. You're going to distribute 3 times x and 3 times the 1. So that's going to come out to 3x plus 3. You still have this minus 5 is equal to 3x minus 2. You then combine like terms that you can. I can combine the 3 and the minus 5. The 3 and the minus 5 is going to come out to a negative 2. So I now have 3x minus 2 is equal to 3x minus 2. When I subtract 3x from both sides, those x's are both going to cancel out. I'm left with a negative 2 is equal to a negative 2. They are the same. So we call that infinitely many. Okay, if we take a look at the last one, hush. I still have 3 minutes with you. Sit down.
Shh, I do.
All right, for here, we don't have any distributive property, but we do need to combine like terms. I can combine this negative 3x and this minus 1x. That's going to equal a negative 4x. Please stop packing up. Especially since quite a few of you that are packing up are also the ones who didn't do so well. Okay, negative 2x plus 7 minus the 2x. We can combine those like terms as well. Negative 2x minus the 2x, that can combine to be negative 4x. We still have a plus 7. We then would go ahead and add 4x to both sides, but that would cancel out the 4x's. We would then be left with nothing over here. So if there's nothing left, what do I put? 0. And that's equal to 7. That is not a true statement, so we put down that there is no solution here. No solution. You do not have homework tonight, but those of you who have missing material, you need to get it done.